Well, I'm Carlos Ríos because Juan Carlos Lancha couldn't attend. Okay, well, I'm going to start because time is short. Okay, so just 1 minute. Okay. Short introduction regarding fatigue design. As you know, not every structure is fatigue sensitive. Standard buildings, small span bridges, road bridges mainly, etc., etc. A lot of structures are not fatigue sensitive, but there are several structures that are fatigue sensitive. Railway bridges, of course, up to a certain degree, road bridges, of course, structure supporting machinery of any type, rolling stock, crane bridges, etc., etc. And of course, support structures for wind turbines, both onshore and offshore, that in my opinion are the most sensitive fatigue structures, okay? And fatigue design is absolutely determinant for the design of these kinds of structures. Okay, so as you also know, these kind of structures for support of wind turbines are, more and more common. Okay, and there is a lot of plans, okay, to further construction, especially of offshore structures. Okay, regarding fatigue failures due to fatigue in reinforcing and pre-stressing concrete, of course there are some known cases. Of course, for reinforcing steel, there are known cases, as I said. Okay, for concrete, fatigue of concrete, to my knowledge, there are a little literature about known failures. Okay, I took a look to some possible failures, mostly in concrete foundations for wind turbines. Okay, and definitely I can say that concrete can fail due to fatigue, under compression, under shear, etc., etc. Okay. And regarding this topic, fatigue design, which is not a common topic, as I said, a lot of structures don't need a fatigue check. Okay, we need to take into account that the structures are more slender, concrete has more strength, we have a high strength concrete, ultra high strength concrete, etc., etc. We have very slender members, etc., and fatigue design could turn out to be critical for the design of these members. Okay. Regarding cases to be considered, okay, in the new Eurocode, the same list of structures that are not fatigue sensitive, okay, is kept. Okay, it's the same, more or less, with some exceptions, and in the current Eurocode. But there is an important thing that I think I should mention, and it is that this Eurocode doesn't exclude specifically offshore structures, okay? Now, in the former Eurocode, you can see that there is a statement saying that this part one does not cover offshore platforms. Sorry, because the red rectangle is not in the right position. Okay, but in the new Eurocode, there is no specific mention about the design of these kind of structures. And I think it is fair to mention that the current the new Eurocode, the fatigue provisions of the new Eurocode are not suitable for the design of offshore concrete structures because it is not taken into account structural concrete in water, okay, humidity, which is widely known that it is a reduction factor for concrete strength, and also the possible influence in the fatigue of the reinforcement. Matter in fact, in some guidelines, specific guidelines for the design of structures for wind turbines, it is stated that you need to use a specific SN curves for the reinforcement, okay? Now, regarding methods of verification and combination of actions, we have now 3 levels of verifications. They are not mentioned in the slides, okay, but we have the simplified approach, okay, which is quite suitable, okay, for small structures, not highly sensitive to fatigue. We have the damage equivalent load, and of course, we have the paragraph minor rule that now it is included in the general chapter for fatigue, which is chapter 10, okay, in the new Eurocode, okay? This rule, which is a standard rule for a refined analysis, for an accurate analysis of fatigue behavior of structures, the paragraph minor rule is included in the current Eurocode in part 2 for bridges, but it wasn't included in the general part, so it was a kind of exclusion for its use for other type of structure other than bridges, okay? Regarding combination of actions, the combination of actions for fatigue, there is significant change because now the fatigue load combination is a quasi-permanent combination, okay? Every other load, which is not a cyclic load, shall be considered as if they belong to the frequent combination, to the quasi-permanent combination of actions, instead of the frequent combination of actions that was the provision is the provision in the current Eurocode. So there is a slight load level reduction for the verification of fatigue design, and of course, for some actions like WIN, where the quasi-permanent factor is 0, okay, WIN vanishes from the fatigue load combination, but WIN is important for fatigue if it is the lead action, okay? And just one comment here, okay, which I think it is important, okay, because some people said that this combination was used also to check if the concrete was cracked under the fatigue load combination. Because of course, if the concrete is cracked, okay, reinforcement is going to suffer a lot more, etc., okay? But it is important to say that the current Eurocode and the new Eurocode does not cover concrete under tensile stress cycles. So you need to consider always the concrete crack, okay? Unless it is compressed, okay? But you can take into account the tensile strength of concrete, if there are fatigue loads, okay, because Eurocode 2 does not cover this kind of fatigue failure, okay? Now, regarding point 4, internal forces and stresses, this is related with what I just said, okay? No tensile strength of concrete shall be considered, okay? There is another novelty, which is kind of important, okay, for an accurate assessment of certain details, especially for instance for offshore structures when you have special joints, connection, etc., which is that now in the new Eurocode is taking into account the redistribution capacity of concrete, okay, under fatigue loads, okay. And this occurs when there is a stress gradient in the concrete, okay, and it's widely known. It was in the Model Code 90, it is in the Model Code 2010, and in other codes and guidelines, okay. It was proposed to include this approach, okay, directly from the Model Code 2010, but it was modified, and the provisions to take into account this redistribution capacity is very, very simple. Okay, you just need to check concrete fatigue of concrete at a fever 100 millimeters away from the most compressed fever, which is a very important simplification. Okay. Because we find we face, okay, a lot of structural details, okay, of concrete under cyclic loads where redistribution is you need to take into account this redistribution capacity of concrete under fatigue loads, okay, and of course there are nonlinear gradients, there are nonlinear distribution of stresses, etc., okay. So in those cases, of course, this approach is not valid, and you need to be a little bit more careful, okay, with the possible design, okay. You can see here just an example of our work regarding this kind of redistribution, okay, when you have nonlinear stress gradients as in the regions of concrete structures, okay. Regarding reinforcing steel, okay, because for pre-stressing steel, there is no significant changes, okay, but for reinforcing steel, there is a whole new set of SN curves, okay. there was an extensive research of TNO at Netherlands regarding fatigue of reinforcing steel, okay, mainly non-welded reinforcement, decoiled reinforcement, and welded reinforcement, okay? So SN curves has changed for both non-welded and welded reinforcement. For non-welded reinforcement, the diameter is now included. It is not included in the current version of the Eurocode, but now it is included, okay? We know there is a size effect, okay? And now it is included, okay? And the number of resisting cycles at the knee has changed from 1 million to 2 million, which is a standard figure, okay? For instance, for structural steel, okay? And there is another provisions which are, for me at least, and for the design of, for instance, shear reinforcement, which is important, like this one that you can see here, the green arrow, which is said that when you have a bend, okay, for a standard hook with 90 degrees for stirrups with diameters less than 16 millimeters and a depth larger than 600 millimeters, you can avoid the influence of the bend in the fatigue design of the shear reinforcement. And then this has an impact on the design of shear reinforcement under fatigue, bridges, and other kind of structures, okay? We can see here the new SN curves of the new Eurocode compared to the current one, and you can see that the inclusion of the influence of the diameter has some impact, of course. For diameters lower than or equal to 12 millimeters, we have better SN curves, okay? For diameters larger, we have worse SN curves than in the current Eurocode, okay? And these curves include the decoiled bars, okay? Because it was important to study what was the influence of the decoiling of the bars, okay? Up to a diameter of 20 millimeters, which is the maximum diameter, which usually is the coil. Regarding welded reinforcement, it was this extensive research, TNO, okay? As you know, welded reinforcement is more and more common, especially for precast elements and other kind of structures, okay? And SN curves has been modified, okay? For the welded reinforcement, the number of resistance cycles at the knee has changed from 10 millions to 2 millions, okay? And we can see something similar to the non-welded reinforcement. If you have low diameters, you have an improvement in the SN curves. If you have larger diameters, the SN curve is a little bit worse than the current Eurocode, okay?
Carlos, 2 minutes.
Okay. Regarding concrete, okay, there is a lot of controversial, okay, but concrete fatigue has been improved a lot, okay? Fatigue of concrete is a very difficult research topic, okay? There is a lot of opinions, but now it's implemented, okay? A new SN curves that, as you can say here in this comparison of SN curves, this SN curves has improved significantly compared to the current Eurocode. But if we compare these new SN curves with the curves provided in the Model Code 2010, we can see that the change is very small, okay? So I think we are covered, okay? Some topics that are not covered, I want to insist, okay, because this was discussed, there was no time, there is no clear research backup, etc., etc. Concrete in water is not covered. Concrete under stress, tensile stress cyclic load is not covered. Tensile compressive stress is not covered also. And this is a dangerous situation, but it's not common. For instance, in bridges and other gravity resistant structure, low frequency loads, and fatigue of bone, okay? And finalizing, okay, because there is no more time, regarding shear, okay, there are some changes. Now you are allowed to calculate accurately the multi-axial stress state, which is shear, okay? Because now you can calculate with the provisions that are in the Annex G, okay, the inclination of the strut angle, etc., okay? And this way you can avoid the simplified formulation that is kept in the new Eurocode, but it hasn't a rational base. Okay, so now you can do that. There is an formulation for shear interfaces, very favorable. Okay, you can avoid check of reinforcement and concrete strength at shear interfaces. Okay, you comply with several provisions. Okay, and now there is an open door. Okay, to check thoroughly the multi-axial stress states in concrete when you have the axial stress state, 3D stress states, okay, because now you are allowed to take into account the softening of concrete, etc. If you accept that concrete under fatigue loads and multi-axial stress state behaves in the same way that under static loads, okay? Confinement, more or less the same, no provisions for confinement. We need to be careful with confinement, okay? There has been a lot of failures because of considering a huge confinement equal to that of the static loads, okay?
Carlos, we need to finish.
Yes, and bridges, no significant changes at all.
Okay, thank you very much.
Thank you.